Good morning, guys. So, before starting with EIGRP, my concern here is to discuss second type of routing protocols. Second type of routing protocols. Guys, when we discussed about RIP is what kind of routing protocol? Distance vector. All of you know the meaning of distance vector? And we have a condition in RIP, all of you know this thing, that whenever a link goes up or down, there will be a update. It's necessary. This thing is clear? That particular update is called triggered update. This thing is clear? Next thing. Today we have to discuss second type of routing protocol, that is link state routing protocol. Now guys, the thing is, why we call some protocols as link state? First thing is this, if we know this thing, we can understand link state routing protocols. सबसे पहले हमें यह पता होना चाहिए कि मैं किसी प्रोटोकॉल को लिंक स्टेट कहूंगा क्यों? इसका मतलब it means there is something different from distance vector. Agree or not? Okay. First of all, we will discuss some key points of distance vector. What are the problems with them? Then we will come to link state. This thing is clear. Guys, why we move from one technology to another? This thing is very important. You must know the reason. Interviewer can ask you a question. Why someone moved from distance vector to link state? What was the problem with distance vector? This thing is clear. So, let us discuss some key points of RIP. Sorry, distance vector, not RIP. All distance vector routing protocols use hop count as a metric. Agree? All of you know the meaning of metric. Metric is used to select best path. Guys, is it necessary that the shortest way is the best way? Is it necessary that the shortest way will be the best way? Okay. Like your parents always tell you, please do hard work. Don't follow short ways. Why they are saying so? Because they are not reliable paths. Yes. Okay. Let me give you a technical example. I have a topology like this. What is the bandwidth of a serial link? What is the bandwidth of fast Ethernet link? What is the bandwidth of serial link? Any issues? Now, which path will be used? R1, R2? Why? Because of least hop count. Agree? Now, what is the bandwidth on this link? Okay. What we assume that if a road is of 100 Mbps, we have a big road. This is 100 Mbps road, and this is 1.54 Mbps road. Data will flow more over this road or this road? More over 100 Mbps road. Agree or not? So, I have a better path. but still I am using the worst path. This thing is clear. This is a problem. If I select best path only on the basis of hops, this is a problem. See, whenever we have to select best path, router must check bandwidth of link. Yes, because bandwidth is defining how broader your road is. If bandwidth is high, router must select the high bandwidth path. Agree or not? It means best path must not be selected on the basis of number of hops. This thing is clear? Now, I can tell you a case. Case is like this, guys. R1, R2, R3, R4. This is the case. In this case, for R1, R3 is advertising a network, let's say X, with mask 24. R3 will advertise it to. R3 will advertise it to. R4 will advertise it to. R2 will advertise it to. Now, first thing, this is routing table of R1. First thing is checked. X network 24 mask. From both the sides, I am getting the same prefix length. Agree? There is a tie. Second thing I will check is AD. From both the sides, the route is a rip route, so AD is also same. It means I am getting X by 24 from R2 also and R4 also. Agree? Third thing, metric. What is metric for rep? Number of hops. From both sides, number of hops are. Three things are same. It means router will perform load balancing. Agree? It means router must use both paths to send data. Agree? Just think like this. It is a big road. If router will divide data equally, there can be a chance. On this small road, there can be congestion. Or delivery of data on this small road is slow as compared to delivery of data on this big road. Agree or not? So what will happen? R3 will not able to receive data at same time from both the links. This particular thing is called congestion. This particular thing is called. It means when we are using hop count as a metric or hop count to select the best path, there is a chance that in my network congestion can occur. This thing is clear because router is not considering bandwidth to calculate the metric. What router is considering? Hop count. It means hop count is a problem. Agree? Second thing, in case of distance vector routing protocols, what we have? Periodic updates. There are no don't call it incremental, call it there is no partial updates. This thing is clear. What do you mean by partial updates and what do you mean by periodic updates? Or you can say full updates or triggered updates. Okay, I will discuss these 4 terms with you people when we will complete all 3 routing protocols. Just to make the difference clear, what do you mean by different updates? I have categorized it like this. Let us discuss these 6 terms. First term is, I will compare all 6 terms when I will complete 3 of the routing protocols. What do you mean by periodic? After a period of time I will send the update. It is necessary or not, I will send the update. Like RIP. RIP always send update after every 30 seconds. Agree? What are incremental and triggered? When there will be a change, I will send the update. RIP also support triggered updates, but that is not in your syllabus. But we discuss one thing, when there is a link up or down, RIP will always send triggered update. This thing is clear? Second thing, full and partial. What do you mean by full updates and what do you mean by partial updates? See, like Sagar and me are routers. We are connected together. For the first time, we will always share full updates. All of you know RIP is a distance vector routing protocol. In case of RIP, there will be periodic update. It means after every 30 seconds, we will share full updates. Again, agree or not? What do you mean by full updates? Full routing table. Agree or not? What do you mean by partial update? Partial update means, okay, let me explain this thing to you like this. This is R1, this is R2. A, B, C. Network D. R1 is giving information of A, B, C to R2 after every, it means periodic and full. Agree? R2 is giving information of network D to R1 after every, it means full and periodic. What do you mean by partial? Partial means if I am adding a network E here, which network? R2 only sends information about network E, not full update. This particular thing is called partial updates. That I am just sending the change, not the full thing. Fine. सिर्फ मैं E के बारे में बताऊंगा किसको? R1 को. I will never tell about D to R1. Yeah, when there is a new network added, there is a change. Change can be of anything. Yes, change can be of anything. Change can be in metric also, bro. Yes, we haven't discussed till now how you will change the metric. Agree or not? But metric can also be changed. This thing is clear? Fine. This thing is clear? What are full and what are partial? What is bounded and what is unbounded? This thing I will discuss in the end of EIGRP. This thing is clear? So, first problem is clear. First problem is for different distance vector routing protocol is that they are using metric as. Second is they are sending periodic updates. Any more problem? Yes. Distance vector routing protocols perform routing by rumor. What do they perform? Routing by. What do you mean by routing by rumors? What are rumors? Of wine. Fake news. Okay. R1, R2, R3. Fine. R3 has a network B. When R3 will send an update to R2, source in the update will be. When R3 will send an update to R2, source in the update will be Y2. Destination in the update will be. Depend upon routing protocol. Network will be B. It will be received by R2. R2 will install in its routing table like this. It is a rip route. Which network? B. Next hop is Y2. Agree? Now when R2 will forward this network to R1, R1 will forward it like R2 will forward it like this. Next hop source in the update is X2. Destination will depend on routing protocol. Network is B. It will give it to R1. For R1, route is of RIP. Network is B. Next stop is X2. According to R1, is there any router called R3? No. R1 does not know about R3. It means for all the routing information, a router is dependent on the adjacent routers. They do not know any router which is one hop away from them. This thing is clear? This thing is fine. So this particular thing is called routing by. Remember, see, for all the networks of R3 I am dependent on R2. I actually don't know about R3. If there is R4 also, I actually don't know about R4. This particular thing is called routing by rumor. Okay. I discussed a case with you people. In that case, R2 was advertising information of a network, but R2 was not getting the update. You remember the case? The day we discussed timers. R1, R2, R3. See, I configure this interface as passive. R1 stopped sending updates too, but R2 was still advertising updates too. For R3, the network still exists on R2. This particular thing is called routing by rumor. What my concern is, if network is down, all the routers in the topology must know that the network is. There must not be routing by rumor. This thing is clear. This is also a problem of distance vector routing protocols. We have discussed some problems. Now we will discuss what are link state routing protocols. Now, guys, link state routing protocols, the perfect example of link state routing protocol is OSPF and ISIS. What is OSPF? Open shortest path first. What is ISIS? Intermediate system, intermediate system. These both routing protocols are basically used in service provider networks. Because of which behavior? Link state. This thing is clear. Now, what are link state routing protocols? First thing about link state routing protocols, there will be no routing by rumor. There will be no routing by. What I am trying to say? Okay, I will explain the process like this. This is R1, this is R2, this is R3. R1 will build its own database. What R1 will build? Database. First thing, R1 will build its own database. For what thing it will build the database? I am writing the whole thing here. For the networks which are connected to R1. For the networks which are connected to R1 will build database for them. Let's say the network is A and B and C. R1 will build a database in which there will be entry for 3 networks A, B and C. Agree? Any problem till now? R1 will mark that database as D1. Agree? Now R2 is also having 2 networks C and D. R2 will also make a database of which network? C and D. R3 will also make database of which networks? E and F. R3 will mark database as D3. R2 will mark database as D2. Now what thing will happen? They have their own database. First of all, router will try to find a neighbor to exchange their database. Okay. It is like this, yaar. I have some new information. With whom I can share the information? No. The one who can understand me. Okay. I will give you a example. Just think like, what is my problem these days? I have a link of 100 Mbps. Fine. A user is sending a TCP SYN packet on this link. I want to check when TCP SYN is flowing through this link, how much link is utilized. I have a problem, I have a doubt. With whom I will discuss? I can discuss it with you. For you it will be a shit. You will say, what you are talking about, Piyush? Yes. What is the question? What you will get to know after knowing this? Yeah, this is my concern. I want to know this thing. Agree? So I will discuss this thing with the one who knows this thing, who is compatible with me in knowing this thing. Agree or not? It means what router will do? Router will try to build compatibility, or you can say router will try to build neighborship with the directly connected routers. But it is not necessary that every time a router is able to find a neighbor. Like here I am trying to find a neighbor. I discuss my problem, but there is no solution, so I will not form neighborship because there is no compatibility. Agree? It means for becoming neighbors we need one thing, compatibility. Agree or not? So what these routers will do? Okay, I can do one thing here. I will just consider R1 and R2 for the first time. Fine. R1, R2. Here are some networks A, B, C, D, E. What a router will do? Try to understand the properties of link state routing protocol. First of all, router will try to discover neighbor on the interfaces. Which interfaces? RIP was sending update on which interfaces? Which were advertised by network command. Which were advertised by? OSPF will try to discover neighbor on those interfaces which were advertised by network command. This thing is clear? I am writing here networks which are advertised by network command. Agree? Any issue? After that, what I will send to discover a neighbor? Like, I was having a problem. I discussed with you people. What is my problem? Do you have a solution? No. It means you are not compatible. What routers will check? Router have some parameters to match. This router will send a hello. What it will send? Hello. In hello, there will be some parameters which will be received by R2. R2 will also send its hello. But the condition is when router will send hello. Router hello send कब करेगा? When this particular network is advertised by network command. If this particular network is not advertised by network command, they will never share hellos. This thing is clear? All things are working like RIP. In RIP, when you advertise a network command, what will happen? Two things will happen. One, router will start sending update on the interface on which you are running that network. Agree? Second thing, router will include that network in the updates. What thing will happen in case of OSPF? When you write on R1 network A, network B, network C, network D, on all the interfaces where you are running network A, B, C and D, router will start sending hellos to discover a neighbor. Second thing, when router will send an update, router will include the networks you have advertised by network command. This thing is clear? This thing is fine? Or you can say router will use these networks A, B, C and D, the networks you have advertised by network command, to build its database. To build its database. This thing is clear? Fine. So now what R1 will do? R1 will try to discover neighbor over which interface? Over A also, B also, C also and by which message? Hello. R1 will send a hello message to R2. Now on R2 you are running network command for which networks? D and E. R2 will also start sending hellos on D and E. Agree? And R2 will include D and E to form its database. Agree? This thing is clear? Now R2 will send a hello, R1 will send a hello. They will match some parameters and they will become neighbors. So guys, second property of distance vector routing protocol is before sharing routing informations, router will become neighbors. Router will become neighbors. They cannot share routing information directly as they were sharing in RIP. As they were sharing in RIP. This thing is clear? First of all, they will form neighborship with the help of which message type? Hello. And my questions can be like this also. Isko uthao. If a router want to send hello on an interface, what is the condition? Fatabat, what is the condition? बिल्कुल सही. That network must be advertised by network command. I can ask a question like this also. If a router want to include a network in its database, what is the condition? Same answer. That particular network must be advertised by network command. What is the use of network command? Two uses. First, to send hello on that particular interface. Second, to include that network in the database. Clear? Shall we move on? Okay. नींद से जाग जाओ. R1, R2. Now R1 is sending hello to R2. R2 is sending hello to R1. They will become neighbors. Now we will not discuss what are those hello parameters, because those hello parameters will change from routing protocol to, here we are discussing properties of link state routing protocols. कैसा क्लैश? ओके यार, ये तो आपने सही बात कही. आप चंडीगढ़ से दिल्ली जा रहे हो अपनी गाड़ी पे बैठ के, मैं दिल्ली से चंडीगढ़ आ रहा हूँ अपनी गाड़ी पे बैठ के, टकरा जाएंगे हम? तो देखो, दिस इज अ गुड क्वेश्चन, यू नो, दिस इज अ गुड क्वेश्चन. इट्स नॉट लाइक दिस. जैसा आप सोच रहे हो पहली बात तो वैसा नहीं होता. ऑन एवरी मीडिया आई डिवाइड माई मीडिया इंटू टू थिंग्स. तुम्हें कहा था वायरिंग पढ़ के आना. पढ़ी थी वायरिंग? ऑल ऑफ यू हैव स्टडीड वायरिंग? तो डिफरेंट पिंस यूज होती हैं, सेंड और टक्कर नहीं हो जाएगी। Two routers has become neighbors. Fine. Now, to maintain their neighbor relationship, they will maintain a neighbor table. They will maintain a in neighbor table. R1 will be having an entry for R2. R2 will be having an entry for R1. Guys, just tell me one thing. Two routers has become neighbors with the help of which message? Now we need hello. Now we need hello. Yes or no? How many of you say yes? How many of you say no? Why yes? लिंक डाउन पे अभी बात नहीं गई। my question is, hello message was necessary for two routers for becoming neighbors. Agree? Now two routers has become. Do we need hello message? Yes. Why? I will give an example. Fine. मेरी नई नई शादी हुई. Fine. पहली रात ही मुझे मेरी बीवी से प्यार हो गया. हाँ, हो गया. अब उसने मेरे से ले ली कसमें. आप ये भी नहीं करोगे, आप ये भी नहीं करोगे, और आप ये भी नहीं करोगे, और ये तो बिल्कुल ही नहीं करोगे. ट्राई टू अंडरस्टैंड. दिस इज द केस. अब हुआ क्या, अगर मैं उनमें से कोई काम करता हूं, उसे पता चलेगा. एग्री और नॉट. और जो हमारी कंपेटिबिलिटी थी उस पर फर्क पड़ेगा. पता कैसे चलेगा? देखो, दो राउटर थे, मैं और मेरी बीवी थे. चलो ठीक है, मैं नहीं. आपका नाम क्या है? शुभम. शुभम और उसकी बीवी थे. फाइन. शादी से पहले इन्होंने बहुत वादे किए, भाई मैं ये करूंगा, मैं ये करूंगा. ये एक हेलो मैसेज भेजते थे, भाई आज तेरे लिए मैं ये लेके आऊंगा. बीवी भी हेलो मैसेज भेजती थी, थैंक यू, लव यू, ऐसे ऐसे जो भी था वो. लीव इट. होगा क्या, जैसे ही ये अपने प्रोमिसेस से मुकरेगा, ही इज नॉट कंप्लीटिंग हिज प्रोमिसेस. लाइक इसकी बीवी ने इसको कहा, आप शादी के बाद ड्रिंक नहीं करोगे, और ये ड्रिंक करके आएगा. मतलब इसने हेलो का एक पैरामीटर क्या किया? ब्रेक. हेलो का एक पैरामीटर क्या किया? ब्रेक किया. इसकी बीवी को पता कैसे चलेगा अगर हेलो एक्सचेंज नहीं होगी? ये अगर ड्रिंक करने के बाद किसी और के घर पे सो जाएगा तो इसकी बीवी को उस पैरामीटर के बारे में कभी भी पता. तो ट्राई टू अंडरस्टैंड. इफ आफ्टर बिल्डिंग द नेबरशिप R1 says I am changing my parameter and they are not exchanging, R2 will never get to know the parameter is changed. And just to check that the parameters are still the same, router will keep on exchanging hellos. Router will keep on exchanging hellos. और ऐसा भी होगा, आपने 3 से ज्यादा पैरामीटर तोड़े तो आपकी जिंदगी खत्म. नई बीवी ढूंढ लेना. यस. What is the condition? There is, guys, a hello time and a hold time. R1 is saying to R2, what R1 is saying? That I will be sending you hello after every 5 seconds. The time is always dependent on routing protocol. This thing is clear? R2 will also send a hello after every 5 seconds. Now R1 will strictly say to R2, if you are not able to receive my hello for 15 seconds, delete me as a neighbor. इन्होंने अपनी बीवी को फोन करके कहा, आज मैं पी तो जरूर रहा हूं, अगर 15 मिनट में घर ना आया तो दरवाजा बंद कर देना. प्लीज क्लोज द डोर. इट मीन्स we are sending hello after neighborship for 2 reasons. One, to check my neighbor is still active or not. Second, to check the parameters are still the same or not. Agree? This thing is clear? सागर कोई issue? Connectivity देखने के लिए भी यूज होता है. What I am trying to say? What I am trying to say? Look here. अपनी सोच को बड़ा करो कैसे? If this is R1, this is internet, this is R2. You are building neighborship over internet. So there can be a chance R1 is sending hello, but due to some problem in the ISP, R2 is not able to receive hello. So R2 will wait for how much time? R2 will wait for whole time. After whole time, R2 will say R1 is down. After whole time, R2 will say R1 is, what is hello time? After a time interval, I am sending the hello. What is whole time? For the time interval, I will wait for the hello. This thing is clear? Any doubt? For the time interval, I will wait for the hello. Yes.
Like 15 seconds is the limit. So when 15 seconds are over, so it will remove the R1 from its neighbor, or it will stop receiving messages.
It will remove R1 from its neighbor table and it will delete all the entry sent by, all the updates, all the database sent by R1 from its database table. Fine? This thing is clear? So guys, network command is also having two uses, and hello message is also having two uses. This thing is clear? Shall we move on? Next thing. Two routers have become neighbors. They are still exchanging hellos. Now, what R1 will do, like I told you in the beginning, R1 has built a database. Now R1 will give its database to R2. R2 will give its database to R1. This database messages are called, these database messages are called updates. This thing is clear? Any issue? Now, in link state routing protocol, in updates are exchanged periodically, but not after every 30 seconds. After every 30 minutes, we can stop this thing, but this is by default behavior of link state routing protocols. And one more thing, in case of link state routing protocols, we always have full updates, never partial updates. Never. What I am trying to say, if there is some change in database of R1, R1 will send its whole database again to R2. And if there is some change in R2's database, R2 will change its whole database to R1. This thing is clear? So distance vector routing protocols also have periodic updates and triggered updates. But in case of link state routing protocols, we always have periodic updates. We never have triggered or partial updates. Fine. In case of link state routing protocols, updates are always full, never partial. Never partial. This thing is clear? Guys, updates can be R1, R2. This is, let's say, network A. This is network B. So what I will write, router EIGRP 1. My S number is, I will write here network A. After that network B. What router will do? First of all, router will start sending hellos on these two interfaces. For what thing router is sending hellos? To discover neighbors. It means in case of EIGRP, when I define a network by network command, there will be dynamic discovery of neighbor. There will be dynamic discovery of neighbors. By which message? Hello. On R2 I will come router EIGRP 1. I will write here network A. R2 will start sending hello on this interface. Fine. Now R1 is sending a hello, R2 is sending a hello. Now our motive is to discuss hello parameters that they will match. Fine. But before that, let us discuss one thing. When R1 will send a hello, source will be destination will be. अगली बार ये गलती किसी ने की ना, लेक्चर मिस करा दूंगा उसका। 50 बार बता दिए एक बात। सोर्स क्या होगा? जिस इंटरफेस से अपडेट जाएगा। डेस्टिनेशन क्या होगा? डिपेंड ऑन द राउटिंग प्रोटोकॉल। दोबारा नहीं होनी चाहिए गलती। When R2 will send a hello, source will be A2, destination will be 10. R1 will send hello after every 5 seconds. It means for EIGRP hello time is 5 seconds. Now R1 is sending a hello. What is the content in the hello message? One is, second is, first is, second is, condition is AS value, AS number must match, and the second condition is K values. Just try to understand this thing. What are K values? What I meant to by K values? I discussed that in case of EIGRP, how many matrices will be there? How many metric will be there? 5. What are they? Bandwidth, load, delay, reliability. Just think like you gonna marry a girl. It is true. यार आज के टाइम में कुछ भी हो सकता है. All of you know. हमारे शौक, हमारी आदतें कुछ भी हो सकती है. भाई क्या हुआ ऐसे मत देख. डर लगता है मुझे कई बार. ठीक है जी. So it is like this यार. I am R1, you are R2. What's your name? Adil. R1 is saying in the hello message that Adil, I have 5 matrices, bandwidth K1, load K2, delay K3, reliability K4, MTU K5. What is K3? इतना फास्ट नहीं हो आप, मुझे पता है. Right? K1 is bandwidth, K2 is load, K3 is K4 is K5 is MTU. See, in the hello message, I will say to R2 that when I will calculate my metric, I will use K1 and K3. I will use. If you agree on the same thing, then we can form neighborship. Otherwise, no. It means they are not actually checking the K values. They are checking checking the parameters they want to use for calculating the metric. वो उन parameters को check कर रहे हैं जो वो use करेंगे किस लिए? metric को calculate करने के लिए. They are actually checking the parameters they want to use to calculate the metric. What I am trying to say, like Adil and me are neighbors. Fine. I am saying I will use K1 and K3. So what are K1 and K3? Bandwidth and delay. Adil is saying, hey man, I will use K1 and K4. So I will say, okay, we cannot form neighborship. This thing is clear. So K values means here what factors I want to use, what K values I will be using when I will be calculating my metric. Clear? ये मेरे ऊपर है, मैं प्रोटोकॉल चला रहा हूँ, मैं क्या यूज करवाना चाहता हूँ. राउटर बाय डिफॉल्ट क्या यूज करता है? राउटर विल बाय डिफॉल्ट यूज K1 and K3. It means all routers on which you will be running EIGRP will by default use K1 and K3. Agree? मैं आपको पहले एक बात बता रहा हूँ, मैं ये सब चीजें CCNP में डिस्कस नहीं करूंगा. ठीक है जी, कुछ और ही बात होगी वहां फिर. Router will match how many parameters? 2. AS number and K values. So AS number on R1 is, on R2 is matched. Second thing, R1 is saying I am using K values K1 and R2 is also saying I am using K values K1 and K3. Okay, we can become neighbors. So both of them will become neighbors and will install the entry of each other in their neighbor table. Neighbor बना दिए आज, बहुत है, अगली बार पढ़ेंगे आगे क्या होगा. ठीक है, एक चीज और. नाउ दो केसेस, टू केसेस. Why sending hellos after becoming neighbors is necessary? R1 is sending hello, R2 is also sending hello. Guys, सबसे पहली बात, first thing, if you check from perspective of R2, if R2 is receiving a hello, there can be two cases. There can be one, it is receiving hello from it is receiving hello from, or it is receiving hello from a new neighbor. What is the difference between these two things? See, when R2 will receive a hello from an existing neighbor, there is a timer running on R2, 15, 14, 13, 12, 11. When it will reach 11, R1 will again send a hello, because hello time for R1 is 5 seconds. What is this 15? 15 is hold time. So EIGRP is having a hold time of 15 seconds. If a router is not able to receive hello from its neighbor for 15 seconds, it will mark its neighbor as dead. It will remove the entry of neighbor from its neighbor table. It will remove the entry of neighbor from its neighbor table. Agree? So hello time is, hold time is, and what is the importance of sending hellos? Like on R1, after building the neighborship, I change the K values from K1 to K2, K1 and K3 to K1 and K5. So now what R1 will use to calculate the metric? K1 and K5. What R2 is using? K1 and they will break their neighborship. This thing is clear? This thing is fine? It can also be a case that someone changes AS number on R1. So R2 will say, you doesn't belong to my domain. I will not be a neighbor to you anymore. मैं तुम्हारे साथ neighborship, क्योंकि कितनी कंडीशन है neighborships के लिए? दो मैंने जो अभी आपको बताई है कंडीशंस और भी हैं, हमने वो डिस्कस एट CCNA लेवल देयर आर ओनली वन इज, सेकेंड इज के वैल्यू, हेलो टाइम इज, होल टाइम इज, एनी इश्यूज? पढ़ के आना इस सारे को, बात करेंगे।